Good morning, everyone. As you can see, this presentation I'm giving today is about metaphor and beyond. And I'll just get straight to the point. What I believe is that up to now, 3D has been quite a young media. It's only been around for about 20 years, and in the grand scheme of things, that's not very much. And we've been largely constrained by the sorts of tools that we've had to use in other computer interfaces up to now, with the Macs and the standard Windows type things. But I don't think that we have tools that are suitable for communication and interface in a 3D context. And one of the things I'd like to do today is look at how we can perhaps move forward a little bit, or look at bringing some other concepts from different domains and try and make things a bit more richer and more tangible. So, to try and make interaction in 3D, particularly in things like Blender, and but also for other things like games and whatnot, this theory is useful. To make it more natural or interactive and better communication between the user and the computer and the interfaces on a programmer. The two topics I'm going to be looking at today is the topic of metaphor and the topic of what I'm calling in this the visual formalism, which I'll get to a bit later. It's not as technical as it sounds. So, talking of metaphor, some of you might understand metaphor from a linguistics kind of context. And my rough definition that I'm using is a device that takes properties from one domain, concepts and ideas, and applies them to something else. And in language that's used to communicate quickly, rather than being dry and descriptive, you can get a very easy idea of what somebody's talking about if they use metaphor that you can understand. So, for example, a common metaphor in the English language, you could either say, time seems to pass very quickly. That's quite dry and descriptive. Or you can say, time flies. And when you say time flies, you start to get all sorts of images about speed and movement and sort of progression from place to place. And even though you've just said one word, you've got these extra images in your mind about what the person's talking about. So you can communicate a lot of things and inspire a lot of ideas in people just by using concepts like this rather than being totally descriptive. Now, in metaphor is a tool that's been used a lot in interface, and largely, well not largely, but the most common forms of interface and metaphor that you guys might be familiar with, things like trash cans on desktop. The trash can is a metaphor for a real trash can in real life. It's not actually a trash can, because you don't actually put the stuff in the trash can, but it's applying the properties of this trash can to something in the computer in order to make it more understandable or easier to use. But metaphor is more than that, and when I started looking at this topic last year, I did indeed think that it was just a lot of this real life things like trash cans and desktops. It's a bit silly taking these concepts in real life if they don't perfectly apply. But as I started to look a bit more further into the topic, it's used in a lot more subtle ways. And if we can understand the ways that metaphor works, we can perhaps make things that work a bit better. So, in this little session, it may not be very flashy, it's not going to be very technical, but I hope to explain a bit of the theory behind this sort of communication, a bit of general background information about where I'm coming from, how metaphor works in the interfaces that we can use, what and how metaphor is currently used, interfaces that we see right now, what alternatives are available to metaphors when metaphors are not the right thing to use, and how these alternatives can be used. When these things are most appropriate, when should you choose a metaphor to communicate something or to enable some sort of interaction, when should you do something else, and a brief look perhaps to try and generate some ideas in the rest of the audience, maybe how we can use this in Blender or whatever in the future. So to start this off, when I was looking at this topic last year, in the research, I started picking up all of these ideas about media, interactive media, and it was quite interesting because I found that there are a lot of clues in media theory that can help in interface design, but unfortunately it's not really something that's studied by a lot of people in the software development field. Media theory is to do with how information is communicated from one person to another or from one person to many people. And because 3D is now integrating a lot more concepts and a lot more media, it's not just about something that you see in front of the screen right now. There are a lot more new things which are being developed, more abstract concepts. You can have crowd simulation, dynamics, and these sorts of things are things that you can just reach out and touch. It's integrating a lot of different media types. Yeah, that's right. Okay, so to start off describing how these sorts of theory can apply to interface. You probably have heard the phrase, the medium is the message. That was by a guy called Marshall McLuhan in, I think, the 1950s or 1960s. And he was probably one of the first media theorists looking about how media affects the way we communicate and the way we understand things. And a lot of people at the time thought he was crazy because he used quite bold statements like this, which are obviously exaggerated, but he went on to quite a few concepts that we're now finding out. And what he was interested in is how the medium influences the communication that passes through it. I should probably, forgot to write this in my slides here, but I should probably take time to just give a short definition of how I'm going to be referring to these concepts. You can call something a message or a content, and that is what you're trying to communicate through to people. But when you communicate to someone, that content, that message, it passes through a medium. So, for example, you have a newspaper and an editor writes an article, and to get to you, that article passes through the medium of the newspaper and into the recipient. And media is just the plural of medium. So, say, most people refer to the media, and that's all the different mediums that we have available for using communication. And one of the things that Marshall McLuhan started seeing, because he was around at the time that television was just starting to get a bit more familiar to people, is that when you develop a new technology or a new media, you can't always envisage what's going to happen when you bring it in and how it's going to affect people. So when we create a new invention or a new medium, most of it is fairly obvious. We understand what it's supposed to do. We understand generally what its advantages and disadvantages might be. But after a bit of time and a bit of experience with this, we start to see that there are a few effects which we weren't aware of when we first invented something, and they call these unintended consequences. And the reason for this is that any type of medium is structured in a certain way, and the structure of that medium can influence the communication that passes through it. There may be some sorts of limitations in the medium. So, like a newspaper is not very good at communicating time-based information, and these sorts of constraints or tendencies in a media will influence the way that people communicate through it and the sorts of things that people can communicate through that medium. And many of these consequences come from the fact there are conditions in our society that we don't take into consideration. There may be cultural or religious issues that influence the people that develop a new technology or a new media, causing it to be sort of biased in certain ways. There may be historical precedents where if somebody has done something a certain way before, we might continue to do something in a certain way rather than trying something completely different. And there are all these sorts of things that influence on how we communicate that we're not really aware of when if we think it's just words coming straight through a screen or a page or something to us. And McLuhan wrote, it's only too typical that the content of any medium blinds us to the character of the medium. And much of his work so far has been used to think about the negative effects of media. People talk about the TV generation, where people have low attention spans and communication is reduced to short sound bites and things like that, which limits intellectual discussions. Oops. Yeah, so I've already gone through this. I'm going to switch slides. So how does this influence work? I read a little article by a media theorist called Neil Postman, and he looked at US presidential debates in the 19th century and the 20th century. And what he found is that in the 19th century, when the dominant media at the time was newspapers and writing, that the arguments by the presidential candidates were very strictly structured. It was like a linear progression from setting out your arguments and coming to a conclusion at the end, like an essay. Whereas in the 20th century, you can see it now even with the US presidential debates, it's very point for point and it's short sound bites, and somebody says something and then they rebut it in another way. And you can attribute this to the way that the sorts of effects that the media has on how it's communicated. When things are written, you tend to do something in a much more structured way. It's much more linear and it's like an essay. But on TV, it works in a different way, and so people communicate in a different way to try and get why does it get the most out of it, or that's just all they know. So that's an example of reflecting the structure of printed writing versus TV. So the big difference that I'm interested in here is that there are various types of media. Print and writing, it works on fixed definitions. You have a word and it means something, and you can find it in a dictionary. If you can have the word cat and you know it means a cat, if the medium itself is disconnected from the content, so somebody who knows linguistics or something will know this as semiotics, that the word C-A-T doesn't actually, it's quite arbitrary. It could look like a Chinese character. The meaning is not the same as what you actually see on the, whatever it is. It's symbolic, and it's a symbol for what you're trying to represent. And things like print and writing, you can reduce it and deconstruct it into small parts. You can take a paragraph and chop it up into sentences and chop that up into words and then into characters and things like that. And as I mentioned before, it makes meaning through a sort of disconnected fashion, and it's generally a bit more abstract. You compare this to TV and video. TV and video, the meaning is not made from a strict definition. The meaning is made from a context and a relationship. So if you see a picture of a cat walking along the road, it doesn't mean something like the word cat has a very strict definition. If that picture of a cat walking along the road was followed by a picture of a dog running, or if the picture of a cat walking along the road was followed by a picture of something completely different, like a space shuttle taking off, it changes the meaning completely. But it's much more based upon relationships and context, and it's not dependent on fixed definitions. The other interesting thing about things like TV and video is that when you look at something on a TV screen, it's structurally similar to what you're actually communicating, unlike writing. So if you see something on TV screen that represents a cat, it actually looks like a cat. But if you see something that's written that represents a cat, it's just a squiggle that looks like this, and it doesn't look like a cat. It's completely symbolic. And you can't reduce TV and video into smaller units, and it's much more about concrete meaning. It's much harder to convey abstract thought in a visual meaning like that. So, moving on. New media is being created very quickly. You go back 4,000 years and they're developing writing. To the time between developing writing and the time between the printing press is about 4,000 years. You look at things that are happening now, you've had TV and video and the internet and virtual reality and all sorts of new media which are all popping up at this point in time, and it's happening incredibly quickly. And as I've been through before, since the media influences the communication, when a new media, and it influences people's methods of understanding things. And when a new media is introduced, it's common for the new media to sort of repurpose styles and structures formats of past media. And an example that I found is in the early 1950s TV shows. They were quite different to the TV shows that we see today. They were structured very similarly to radio shows that came before it. You'd have a person sitting at a desk and they'd be talking to someone else. You didn't have anything like going out in documentaries and things like that, because people understood entertainment and communication in terms of radio, and so they brought that across to TV because that's what they knew. And this is called, well, in the sort of media theory circles, it's called remediation. And this is happening a lot in 3D. This is where it starts to come back to something relevant to us. Because people's known methods of understanding and known structures for thought in computer interface is generally based on the sorts of things that we've had over the last 20 years, and the interface in windows and buttons and text and numbers and things like that. We're also bringing that across to 3D. But 3D can be quite different as a media format to the sorts of things like word processors and desktop systems. It involves a lot of different concepts, but we're still using the old structures for communicating between the user and the computer. And while this is not necessarily a bad thing, because people are familiar with it, and at least what we've been doing in Blender is trying to bring things up to a kind of base that we can work on with the menus and soon sort of better organized buttons and things like that people are familiar with. I think it would be good to then continue on and use that as a base to start exploring new things which might be perhaps a bit more relevant to what we're doing in 3D. So, I've been talking about media, and that is that interface itself is a form of media. If you look at, there's one-to-one media, where it's like a personal letter or a phone conversation, and one person is communicating to the other, and maybe responding back as well. There's things like mass media, where one person, an editor of a newspaper, is communicating to a lot of people, and they can't communicate back. I consider interface as media, because the interface itself in here is managing the communication between the user and the computer. The interface is what mediates the communication. The communication goes through the interface in the forms of the dialogues and buttons and everything we see on screen goes through the interface, ends up in the user's brain, and then likewise the user takes it out of their brain, sends it through the interface, through their input devices, and back into the computer. And so this is why interface is a form of media, and the study of media theory can help us in that sort of regard. You might even like to think that it's an extra step, and that's the programmer or the designer sitting outside and feeding things into it like this. So, interface and metaphor, how does this relate? Okay, as I mentioned before, there's this idea of media remediating other media. You're taking things from a previous media into a new media. And surprisingly, or maybe not so surprisingly, this is a metaphorical process, as I defined it at the start. Metaphor is taking knowledge and information from one domain and bringing it to another domain. And yes, media uses metaphor by mapping the concepts and knowledge from a well-known source domain to another new target domain. And that's what happens with interface metaphor. We're taking information from a well-known domain and bringing that to something that is not quite so well-known and able to, in order to do these sorts of things here. And metaphor can be used for a few different things. The general sort of classification I'm using is familiarizing, and that's applying familiar properties to make something understandable. So, an example of this would be a computer file system, rather than saying, oh yeah, this is your document, but it's just a few magnetic particles scattered across the disk and it's all in various places and they don't have to line up. That's very hard for people to understand. But if you say, oh, you're saving a file in a folder, and that folder's in another folder, and that's in a filing cabinet, people know how to use filing cabinets, it's familiar to them. And so it makes this new context of bits on disk much more understandable. There's another type of metaphor which I call transporting metaphor, and that is enabling functionality in something by associating it with something else. So an example in Blender would be a knife tool. It's not done in a way like a Connect polygon tool in Maya or something like that, but it's using this idea as a knife to guide the functionality. So you can cut it, and that's how it works. It's referencing something else in order to make a tool. And there's another type that's inspiring, and that's coming up with new ideas by reference to other things. And an example of how this could work is, say, in 2D photo editing, 2D imagery, that sort of thing. At the core of it all, the concept is still the same. It's a grid of pixels, each with a certain colour. But depending on how you think about it, you can inspire different ideas in different tools. So if you think of an application like Painter, they say, oh, what if those pixels are actually a canvas? Then you get ideas like, we can have these natural brush strokes, and if you put a brush stroke over the other one, the paint interacts and does things like that. And you can have smudging and seeping into the canvas, and you get a little palette to mix the colours just like painting. And so by framing it in a certain way, you can come up with ideas for how to work with it. On the other hand, you can have something like Photoshop, where they say, well, what if this grid of pixels is actually a piece of photographic paper in a dark room? And so then you get things like a dodge burn tool, like in a dark room. You get cropping, and you get exposure correction, and cleaning dust and scratches built up. So you can think about topics in various ways, and that will sort of guide the ideas that you come up with for what you're supposed to be interacting with. This is in the same way that the media influences the message. The metaphor is influencing the way that people think about the problem, the way of understanding the interface that you have here. Okay. The two common examples which I want to have a look at today, which is used a lot. I'm not particularly interested in things like trash cans and desktops, but there are a few general ideas, and those are this idea of manipulation and an idea of navigation, which are metaphorical concepts which happen a lot in interfaces. As I mentioned at the start, the metaphor is taking something from one domain and mapping it to another. And not only is this mapping conceptual, it can also be physical. So, if you're working in something in a program, you're mapping the input devices, you're mapping the movement of the mouse on the desk to the movement of the pointer on the screen. And there's a lot of information about doing this in 3D. I found a really good paper, which I'll try and put on the Proceedings website, called Theoretical Foundations of 3D Metaphors. And this guy has gone through all sorts of different ways of interacting in 3D with a 2D input device. And it covers things like the trackball and turntable, and moving through 3D space, and moving with the objects in 3D space. And it's way too much for me to go through now, because it's like 30 pages. But it's really interesting if you want to have a look at the sorts of methods that are available for mapping a 2D input device into a 3D space. So the first one, manipulation. Manipulation is quite common. It happens in a lot of different interfaces, and it happens in a lot of different layers. The idea of manipulation is that the user's input is manipulating something that's happening on screen. So if you press a key, a letter appears up on there, or as you take it to a much higher level, you can drag an object in 3D and it drags on the screen. So the idea of that is that the user feels in control. It's a different concept to say, back to the example of moving something in 3D. You can type in a number and say, I want this object to be here, or you can just manipulate it yourself in the viewport. And this brings a sense of familiarity, a sense of control, because people can have the visual feedback of what's happening and they can understand what's going on. And it uses the same sort of familiarity with manipulating objects in the real world. I know that if I want to move something in the real world, I can push it like this. And the same thing happens when I push my mouse on the screen and move something across like that. So even though using direct manipulation techniques could involve more layers of abstraction in the code, it's not just typing in physical location, a location in 3D space and editing the data of it. If it's done successfully with a good mapping of the 2D mouse to the 3D interface, it can feel a lot more transparent because you can avoid all the abstraction and just deal with the visual form as you see it. Examples of manipulation, of course, as I've said before, you've got moving objects around, and there's some tricky things in 3D when you're moving something on a different axis to what the mouse is moving on. There's interesting things about that paper image. Things like using a knife tool, using paint tools, these all give the impression that you're actually manipulating something in front of you. And as well as this physical mapping of mapping the 2D to the 3D, there's just the general conceptual mapping. So that's using metaphor to map a concept from something that we already know in order to help you manipulate it. So one thing which I found curious because I never actually knew what it was before I used Blender. This idea of an armature. And so maybe if you don't, it's used a lot in play animation. This is what a real armature is. It's a little thing that you stick inside your play model, and it allows you to pose around. This is one I found from Nightmare Before Christmas. And this sort of thing is It's a method of manipulating something in 3D based on how you're used to manipulating something in the real world. And as well as it's the idea of wireframes, that something is joined by wires and edges, like a piece of chicken wire that you can manipulate around. They're all just concepts which people have taken from other sorts of domains and applied to this abstract data in order to understand it and in order to work with it. The next thing which is interesting is the idea of navigation. And this is designed to give the impression that the user is somewhere in an interface and they can change their location and look at different things. And an easy example is navigation on the web. And I think that you're not actually at the website and you don't move to another website, but it's a useful metaphor that allows people to think about where they've come from, where they're going, where they can go in the future, using these ideas that we already have about moving from place to place and looking at different things to sort of structure this interaction in a certain way. And in 3D, the navigation metaphors are ways of being in a particular location in virtual 3D space. There's two types of navigation, and that's relative navigation, where you're moving relative to your current spot. So in Blender, that would be shift middle mouse, dragging the view across, so you're coming from one place to another based on where you were to start with. Or there's absolute navigation, which would be like the period key in Blender, where you're choosing where you want to go and then going there. In the web, that would be similar to relative would be using the backwards and forwards arrows. Absolute would be clicking on the link and actually appearing there straight away. In 3D, there are a few more concepts as well, and this is having the world sort of in front of you in your hands, which you can spin around and manipulate. Oh, no, that's the wrong way around. Being the eye in the hand, which you can sort of look at the world and point in different places, and that would be similar to the Blender's flying mode, where it's like a first-person perspective. And the other technique you can use is the world-in-hand approach, where things are sitting there in front of you, which is like a turntable, a metaphor for the pottery turntable, where you can spin things around and look around them like that. An example which is sort of close to heart for the navigation aspect, which we perhaps will illuminate this a bit more, is the zoom methods in Blender that happened in 2.34. The old Blender zoom method, which is now known as continue, I'll just bring it up. Okay. Oh, it's all. I'll just make a slide. Okay, let's switch to continue. And what happens there is that the mouse movements on the 2D surface that you have right here is being converted to this abstract idea, and it's looking at the pixel coordinates of the mouse pointer, and it's converted back to a more concrete idea of the actual movements in the 3D view. So to demonstrate it, if I move the mouse, does that continue? Yeah, it is. Even though I'm not moving the mouse, the view is still moving because it's looking at the pixel coordinates of the mouse on the screen. Where is the mouse? And then zoom based on that. Alternatively, the new one, which I'm sure you've probably heard me ranting about on IRC and whatnot, is the better one. And the reason I think this is better is that it's a better mapping of these concepts. With Dolly, there's no abstract interpretation in the middle here. It's not looking at the pixel coordinates. To the user, it feels like it's just, I move the mouse back, and it comes back. I move the mouse forward, and it comes back. The movement of the mouse is directly related to the movement on the screen. It's not based on some sort of translation in the middle. And that one is using the current new navigation in Blender, like the platform and turntable, is using the world in hands, like the pottery metaphor. And so that continues, it's like pushing an object away and bringing it back together. It's something that's in front of you rather than you moving yourself forward and back. So the reason that was done is to try and make things feel a bit more transparent and natural by improving the metaphor that's used to govern the interaction. An example of how a metaphor can be used wrongly is, well, not necessarily wrongly, but how different things are appropriate to different situations, and you need to consider what you're actually doing. Is you could say, well, how about we have a walking metaphor for interacting in 3D space? If you have your 3D plane, the ground area, you can walk from place to place and look from place to place, and you can say, oh yeah, people know how to walk in real life, and they'll be familiar and easy for people to understand. But that may not always be appropriate. You could say that it works well in something like a computer game or a VR simulation. If you're playing Quake, it's obviously not very good if you're running through walls and things like that. But if you're in a different situation, like in Blender, where the constraints are being kept on the ground and bumping into walls and clipping and things like that, then it makes sense because in Blender you can just move things to wherever you want and you've got complete control. So walking metaphor would also be inefficient. Well, in my opinion, things like the 3D chat systems which are around, the VR thing, I forget what it's called, Active Worlds or something like that. Because using this metaphor, while it may seem familiar, it's neglecting some of the advantages that the technology has. In IRC, you can just be in multiple places at the same time. You can be in 5 different chat rooms. In a sort of 3D chat system where you have to walk around in a 3D space, you can only be in a certain location at a certain time. And as more examples, it's not useful if you're doing things like visualizing a solar system or a molecular structure, because you can't rely on the familiarity of walking around the world, walking around in real life, because you can't actually walk around the solar system or walk around a molecular structure. So, as well as having a good mapping of concepts that are familiar in the real world, it's also absolutely important that it's relevant and practical for what you want to do. So, if you're going to implement a metaphor, it takes a lot of thought, like how is it going to be used, and what parts of the mapping are relevant, and what parts of the mapping are irrelevant to what we're trying to achieve. It can be quite tricky, but as long as you're thinking about these sorts of things, it's much better than not thinking about them. Okay, so I talked about metaphor, and this metaphor is usually used for manipulation, navigation, things that are quite visual and you can see, and that's the presentational media, a bit more like what I'm talking about with video. It's if you look at an object in 3D, in Blender in the 3D view, the visual representation of that object is what the concept is. If the concept is a sphere, you actually see a sphere. But there are more abstract concepts too. And if the concepts involved don't have real-world counterparts, there's something completely new to 3D, or perhaps the manipulability of metaphors is not good because you want more precision, you want logic and problem solving rather than sort of everyday stuff, then metaphors probably aren't so good. The other thing that I'm interested here that I want to talk about is something that in the research I found they call visual formalisms. The visual formalism is a diagrammatic notation. Basically, it's just something like a graph, or a table, or a flowchart, or a map. It's something that it communicates information visually rather than through numbers and things like that. But also, the difference between that and metaphor is that a visual formalism has a formal definition. It's symbolic. So if you have a map, you also have a key. So a symbol that you see on the key, it says, this symbol means this. So when you see that symbol on the map, it means something definite. It's a much more symbolic form of media, which is much more similar to things like writing, like we talked about before. Because it's symbolic, it doesn't share the same sort of similarity to the content itself. It's detached in a way. There's a lot of existing information out there in information visualization, which we can use to help sort of use for inspiration on how we can use as an interface. There's knowledge out there for distilling significant information to large pools of data, which could be in Blender large, the whole DNA, structs and everything. And there's techniques for distilling that into something that's significant and throwing away the useless stuff. And also in graphic design and information design, there are lots of techniques for presenting this in a way that's meaningful to people, that communicates to people visually. But what I'm interested in is not just taking these visual formalisms like a spreadsheet in Excel would generate a chart or something like that. What we can actually do, which would be useful for 3D, is actually make these formalisms interactive. And in being interactive, they're not just... we can have more interactivity than just being able to choose what parts of this graph or chart to display or zooming in on things like that. But we can also use these other concepts of being able to edit things directly through the visual representations. So, arguments for using visual formalisms as opposed to other forms of symbolic communication, like numbers and text and things like that, is that a visual formalism is visual. The human visual system is very, very, very strong. You've got all sorts of hidden powers for pattern detection, comparison, and contrast. And you can see things much easily in a graph or something like that. You can see trends, you can see things that are abnormal much more easily than looking at a list of numbers. Visually, you can do things like you can show a large amount of people data in a small space. You can take a huge database that's pages and pages long and condense it into some sort of visual graph or visual chart or something that represents that data. It has strong semantics, so it's useful for abstract content and problem solving, and because it's, like I said with the map, it's got strictly defined meanings. It's not like using a metaphor. Well suited to precision and organization, which is what things like maps and charts are already used for in real life. But we can make them manipulable, we can make them interactive, and what we can also do is, rather than having to edit the data itself, like editing the variables within Blender or whatnot, we can actually edit the visual representation of it. An example would be in the OOBS view. We're not actually typing in numbers, but looks is probably a bad idea because it's not as interactive as we want right now. But you can actually do things to the visual representations. You can pick up the data block in the Oops view and then do something with it instead of just typing in numbers. And they're specializable. There's not any sort of hard and fast rules for what a chart or a graph or whatever it could be. We can invent our own ways of communicating things visually. We can combine various things. You can link charts together by graph nodes and all sorts of strange things. And we've got a lot of potential for doing something that communicates quite richly, especially in Blender because it's all built in OpenGL. It's all in 3D. And so we can take these sorts of formats and graphs and things into 3D. So, an example of a visual formalism in practice is an interactive node graph, and it's in all sorts of things. It's in Maya's Hypershade, it's in Wyvern's Crafter, it's in XSI and all sorts of other compositing programs and things like that. And that is a visual formalism. It's a diagrammatic way of representing something that's sort of an abstract flow of information. So when you have it in a shade editor or a material editor, you have information that's generated by, say, a noise texture, and then it follows along the line and gets changed in somewhat by perhaps tinting the color or blurring it or something else, and eventually it propagates along into the end. So it's about a workflow or a flow of information, and it often happens through a hierarchy. This is just something which has been commonly used a lot more in the last few years. So it has defined meanings, so the node represents something quite certain. You can sort of categorize based on different types of nodes. Say this node would be something that generates data, or this node is something that modifies data. But also, we can do things and take it a bit further because what they use in Maya and XSI and Shake and whatnot is pretty similar to just drawing a graph on a bit of paper. And the sorts of things which interest me that we can do further in 3D programs is that we can start experimenting with these forms. We can try taking them into 3D and start playing with things. I've got two examples here which I'd like to show you, which I don't think are in any sort of application that I know of, just in research papers and things like that. One of them is called the CAM tree, or the cone tree. And this is a sort of theoretical way of displaying node graph in 3D, and the hierarchy works by having base hierarchy and the children. And rather than just being laid out in a 2D surface, they're actually laid out in a ring in 3D space.
What is CAM for?
I have no idea. Maybe it's someone's name.
The advantages of this is probably
See better in one of these other pictures.
I think it was cone tree.
Yeah, there's different names. One I see cone tree, one's cone
It
tree.
is a cone.
Yeah,
it is a cone. So I think the traditional name is cone tree.
No. But the advantages of this is that you've got more flexibility in visualizing information than you do with a 2D surface. Because what the interesting part is that you've got a region of interest that you're looking at, and the other stuff can become a lot more sacred. You know, just like the Apple dock, when you move the mouse over the icon in the dock, it gets bigger and you can see it much more clearly. That's what you're interested in. The other stuff sort of fades away in comparison. And it's a similar sort of principle here, because if you rotate this around so that this is in the front here, this is nice and big, you can see the things that it's connected to. And unlike in a 2D surface, if you wanted to concentrate on something, if you zoom into something, if you zoom into something in 2D, the other stuff disappears off the side of the page. But here, if we zoom into these ones, these other ones just get smaller in the background, so you can get an overview of the general structure by using 3D rather than just scrolling around on the page. Obviously, it's not, this thing isn't perfect for everything, but it is an interesting idea of how you can use these sorts of concepts and take it further. Sorry, good question.
Yeah. Could you also publish the variable file this application with your paper for a more interactive experience?
Sure, yeah. I should probably just... Did I even say how it works? It's just basically grabbing on something, dragging it, and it spins around for each one, and the child nodes also spin around with it. But yeah, there are some links to like VRML versions around on the internet that you can play with. Where is it? Another interesting thing which people have been doing to node graphs is they call it using hyperbolic, hyperbolic, I don't know how to pronounce it, space. And what that is doing is it's changing the coordinate system and surface that the graph is on. And instead of being a flat 2D surface, it's projected in some strange way that it's like a sphere. And it uses the same sort of theory behind it, where you have a region of interest. You have an area in the center, which is what you're looking at, and the other stuff sort of shrinks off to the side. You can still see it, but it just doesn't get in the way. I'll just play a little demo movie, which I found on the internet. And so if you click on something, it becomes much bigger. The other stuff goes to the side, but you've still got a general idea of where you've come from and what else is around. So yeah, that's obviously not very useful, but it's an interesting example of how you can just start to play with these different concepts that we already know, like node graphs, but use the computer technology to make them perhaps more interesting and communicate in different ways. Okay, so what can we do about this? About visual formalisms. I suppose that the outliner in language, which you're probably all familiar with, is a small step along the way. It's putting things in a semi-visual organization, so you can actually, it's in a tree, you can see the structure of things and how it's parented, and it's not like showing the name, this is parented to this, but you can actually see it's underneath, it's visual. But it can be done a lot more, and there's all sorts of things that we could do with the OOPS view, perhaps even taking that into 3D and using techniques like we just demonstrated. One thing which I was playing around with last night. Where are they? This is just a silly little mock-up, but what if we use 3D to communicate more information? So you can have you can layer things like having an object up here on the top layer with the object data that's underneath it, and perhaps being able to manipulate things like this would be a lot more easy to understand the structure of things, just like in the outliner. So you can have an object parented to another object, or if you have an armature, you can have a list of bones coming down through layers underneath.
You want to go with the 3D look?
Oh, of course, yeah. I'll submit the patch tomorrow. This is just a silly example which wasn't really thought through very well, but just trying to demonstrate how we can take things a little bit further than just what we're used to in 2D and start playing with things to communicate more efficiently. Okay. There's another area which we could help things by supporting something which is already a metaphor and viewing that sort of, or interacting with it or viewing that information in another way, perhaps using a visual formalism. The idea which I had would be, one thing that always annoys me is that when you're wave painting, say, a joint in an elbow like that, sometimes you miss a bit and there's a little bit underneath. So just as a completely out of the blue, what if you could have a graph of all the different vertices that you're looking at, and you can see, you can organise that graph based on the sort of sharpness of the weighting, so that the difference between blue and red, if it's a nice smooth vein, you can put the vertices on one side. If it's a sharp sort of thing which may cause you problems into forming a mesh, you could put it on the other side and sort of arrange these sorts of concepts visually in order to pick out things. So if you're looking for something which is going to be a horrible deformation, you can look on your graph and say, aha, these vertices up here are like, they're red ones right next to blue ones, and it's going to cause problems. So you could do things like that. You could do things like have a graph that shows in a certain pose how far the vertex has moved from the base position of the armature in order to kind of get it deforming correctly or painting weights. There's just all sorts of different things that we can do to support things which are perhaps more clumsy, the example of the weight paint where you don't have that same sort of precision. And it's supported right now in a symbolic method by the little weight number button that Bassam was talking about yesterday. What I'm interested in is taking this sort of boring numbers and things and making it much more visual and much more rich. And there are so many opportunities that we have to do that in Blender. And of course, it's definitely not easy to code, but it would be very nice. There are a few other sorts of things that you can look at for information visualization techniques, because this is something that interests me quite a lot. This guy here, Edward, I'm not sure how to pronounce his name, Edward Tufts, he's an incredible graphic designer. He's got some great books, one's called The Visual Display of Quantitative Information. And he's got excellent techniques for how to take a huge amount of data and present it visually in a meaningful way and get rid of the crap you're not interested in and show things that are significant. And the work that he's done is just amazing because you can look at something and you just get it immediately, and it's not like going through numbers and trying to understand what they mean because you can just see it right in front of you. There's a lot of designers doing experimental things and things like Flash. These guys are probably not really cool at the moment because they're a bit out of touch and that sort of thing. But I really like these guys, Yugo Nakamura and John Maeda. John Maeda in particular is a bit of a guru. I'll show you his website. He's got some interesting things like that's not very good, is it? Let me try to the cable doesn't reach. The cable's too short. Okay, here we go. This is just a silly little experiment. It's not more of an artistic project with representing time in various ways. Zoom in, it's just a silly little calendar. But there are all sorts of cool, interesting techniques that a lot of people have been coming up with for just different ways of displaying and representing information. And it's really fun to just go through some of the other things that people have been looking at. There's this year Nakamura's site. He's got, I can't even see it, it's a really bad application on this phone. Yeah, he's just experimenting with silly little ways to fiddle with trees, and obviously this is an artistic project. It's not something that's supposed to be used in real life, but
I still will love it.
But by looking at these sorts of things and the things people have done and the sort of things that you see in books about information visualization, perhaps we can come up with clever ideas for integrating these sorts of things in our interfaces, even if they're not specifically like this. That we can steal all the good stuff from them. Okay. So, when to use these sorts of concepts, when not to, when a metaphor is good, when a formalism is good for things. You've probably gathered from what I've been saying is that I think that metaphors are quite appropriate when what you're working on is concrete and presentational. And when these sorts of concepts of like geometry, locations in space, and things that in real life you'd be able to move and touch and things like that. You've got visual things like images and sequence scripts, movies, textures, things which share the structural similarity to the content. It's not symbolic, you actually see what the content is. So I think metaphors are good for this, for the reasons I mentioned earlier, and the abstract and symbolic interactions where we're talking about how something acts, or organising large amounts of data, or doing things that are very complex and you don't have any prior knowledge of how to do these sorts of things in real life, like organising particles and dynamics and game interaction. these are things which I think the visual formalisms can really help with and help people visualize the problem rather than just typing in numbers. So that's analysing the concepts behind a piece of functionality a tool would maybe implemented. You can also analyse the media. So if you know what's going to be in a 3D view, then it may match well with a metaphor that uses these sort of concrete ideas and presentational ideas. If it's something that you know is going to be represented symbolically, like a curve or a timeline, a data block or something like that, then maybe these can be supported by visual formalisms. And although I've been talking as if these are different concepts, they're all often used and integrated together, like in animation. You have something in space, like in a 3D view, but you also have in time, and that's symbolic, like a curve. And these two things can work well together with each other, and it would be nice to find these sorts of ways where we can have different ways of working with the same sort of thing, where the different interface techniques are supporting each other. So if you're deciding what to do, there are a few things to think about. What might be a useful way to proceed in a certain interface. You can look at the processes that you're trying to create. Are they similar to things in real life? Or are they something like a conceptual object in the user's mind which you can manipulate? Do the user's actions result in changes in what you can see? Is it a visual interaction? If you want to choose a metaphor, you can look at things like, is there a good mapping of the concepts? Is it similar to something in real life? Could you just use things like naming and terminology to give an idea of how it works, like the knife tool? The name is a knife, it's not actually a knife. Icons, visualization. These sorts of things can just be metaphor used in really subtle ways. You can look at this, as I mentioned, the familiarization, the transporting, and inspiration. Just do any of these sorts of things. If the metaphor doesn't do any of these sorts of things, maybe it's not a very good idea to use it because it won't be helping very much. And you can look at things like, is there a good physical mapping? Is it something that you can use with a mouse and translate the 2D actions into 3D space? Or is it something that you need to operate in a much more abstract manner? Are we dealing with something like a range of values where you can move something from here to here or expand it from here to here? Is it something that's completely infinite? Are there, say, multiple values that you can map? So if you move the mouse in one direction, it changes one value. If you move the mouse in the other direction, it changes another value. There's all sorts of these sorts of issues which you can think about, and you can find good answers to these sorts of questions, and maybe you might be on the way to using a good metaphor in the interface. So these are all to do with concrete concepts. We could use these sorts of ideas and things in the future in modelling and sculpting. There's always a lot of interest in things like the ZBrush style, displacement painting, UV editing where you're moving things around, painting, navigation. On the other hand, visual formalisms, we could try to see how they can be used in looking at how these conceptual objects be broken down. Are they symbolic? Are we organising large amounts of data versus something more sort of tangible? Obviously, the outlier is this example of organising large amounts of data in a visual way. Are there trends in the data that interact in various ways or relate to each other? If you're looking at a chunk of data which has certain relationships to each other, perhaps it could be visualised in a way where you can see those relationships in a visual fashion. Perhaps if you're dealing with something like an artificial intelligence in a crowd simulator where you're saying, I want them to be doing this 30% of the time, doing this 50% of the time, perhaps it could be somehow useful to use some kind of pie chart or something that communicates that sort of information better. So these sorts of abstract concepts, they could be used in the future in dynamics, particles, game engine, scene management like the outliner, all these sorts of things which don't really have such a strong connection to the sort of visual real-world manipulations. That's maybe what you guys are thinking right now. But I don't pretend to have all the answers, I certainly don't, but at least I'm trying to share some of this information, especially about media theory, so at least you can start thinking about things in a certain way maybe not from such a computer science perspective all the time, and start thinking about the issues which I've talked about when deciding how to implement something or what sort of metaphors could be appropriate. If you have any questions, I'll try my best to answer them, but I'm not a guru, I'm just a messenger. So. But yeah, that just about wraps it up. John.
One question. When using manipulators, you have two kinds of manipulation possible, which is direct manipulation of the effects, quite manipulative. When the operation is too indirect or something like that, you have to manipulate the causes, which is a metaphor of the direct.
The way that I see it is that when you're manipulating an object, that is using a metaphor. You're not actually manipulating the object, it's changing zeros and ones inside the computer, so that's the metaphor. If you have to start doing things which are more abstract and you're changing representations of that data, then perhaps that could be suited to a more sort of graph-like visual formalism. Of course, these are just general ideas and it really depends on what you actually want to do. But the point of what I'm saying is that there's a lot that we can do rather than that's more interesting than just relying on numbers and text and things like that. So if we consider how metaphors could help in an interaction, or if we consider how visual formalisms could help in an interaction, then maybe we can come with something a bit better than what we have now.
This is really fun how powerful metaphors while we do this day or this about the chemistry.
Yeah.
My first thing in my mind was chemistry or what is this? That's what we went about is chemistry. And behind this is the metaphors are metaphors. So if you design things, you call something a chemistry, it can help you to understand what or how it is.
Yeah,
You have to stick to the code thing and you start to think about how can I explore the whole code to the concept. But it immediately puts the picture in the mind and helps you to communicating out with the concept.
Yeah, that's actually a really good example. The word can is a sort of symbolic thing. It doesn't reference anything else, but the word cone does. Even though... Well,
Really was kind
really?
Yeah.
Not for me.
beautiful, yeah.
Okay.
My question is, do we actually need metaphors?
Well, it's not a matter
I'll explain my theory why.
Yeah.
When I first, got interested in Blender, like probably a lot of people thought that Blender was a really revolutionary design. It was like nothing that I'd previously used before. It was difficult to understand because it was a non-standard GUI. When you look at usability and user interface design, it's really in its first phase, its first incarnation, whereby it lends heavily from the traditional, what people are used to. So what it does, it makes the new familiar by using old ideas, i.e. the trash can. So what you could have is where interface design gets to the point when it becomes abstract and it starts referring to itself rather than traditional metaphors.
That's absolutely right, and that's what is happening with a lot of new technology like in dynamics and crowd simulation. But still, when you're dealing with a presentational media, when you're dealing with something that's visual, it's like the example I gave for navigation. When you introduce layers of abstraction between the visual process and the visual end results, it starts to make things a bit more complicated. So if there is something which you can map closely, which is like a visual thing which everybody's used to, and the idea of manipulating something that you see on the screen, I don't think that adding in more abstractions, it would necessarily improve things. I think it's something that you should consider based on what sort of media you're interacting with.
It's the idea of art for art's sake, usability for usability's sake. It's like Design is there to make things easy for people. It's not there to look like anything else or to be aesthetic or whatever. It's like people might not like it, but if it's been tested and the idea's been proven, through maybe laboratory testing or usability testing, then quite often, you have to make that decision just to implement it, rather than the people might not like it.
Sorry, I don't really understand. Can you explain?
Talking about design principle, the idea of, the trash can design, the real user-friendly sort of tools, making your desktop interface quite, familiar. It's like the language that it uses. It's like, the language that people are used to everyday life.
That's only one sort of functionality that the metaphor can use. That's the familiarization type. It's still very useful for other things like the transporting type, where you're associating something with a tool in order to give it some way of working, like a knife tool, or inspiring them where you can think of something in a certain way to come up with new ideas.
Yeah.
The familiarization type, and I agree with you that things like the trash can, it's definitely not always a good idea to just take things from the real world.
Yeah.
Sometimes it can be useful for all sorts of different things.
I have a good friend who's a sculptor, and he just absolutely craves for something tangible, almost to get his hands in and do modelling and things. So one thing that he does like to see is like a virtual pair of hands actually inside the monitor that you can sculpt with, like a lump of clay. So there are uses for metaphor, but I suppose it's getting the balance right, of abstraction and like everyday real metaphor.
Three remarks. You leave out the physical world. You completely talk about interfaces in the virtual world. I mean, we have now haptic devices and we have other things that are more physical. And there's a new revolution in electronics. It's plastic electronics. So I started 1 week ago a new project that's about haptic clay. So we will have haptic clay in 5 years. So that makes quite a difference for user interfaces for modeling 3D objects.
Sure.
So you have really electronic clay. So it's immediately, it has self-consciousness of its own shape on the spot. And you can communicate that. So that's one thing. So I think when you talk about interfaces, you should include the physical side of the interface.
Well, I'm more concerned with what can be done in the here and now, and it's going to be a long time till these sorts of 3D things are come into play. So maybe in 5 years' time we can have a talk about that sort of thing.
Yeah, well, and the second remark, we have a genius on information visualization in the Netherlands, Professor Van Wijken in Eindhoven. He has done very nice things on the Sequoia remap, maybe the ones you saw. Okay. That's rather surprising for your interest for information. And the third remark, tomorrow I have a talk and I will show that also text can be a visual representation. And part of this representation, if you do some coding and throw away all noise in the programming, then you have a very nice visual representation of what you're doing.
Look forward to it. Anyone else? Can?
Talking about programmers using these sort of graphs and things like that. And I suppose if a programmer wants to go and use one of these, you don't have to code it himself to start with, and maybe it would be a good idea, maybe you could see this happening, as looking at different areas where these graphs or curves or widgets basically could be used, and then going and getting a coder to go through and make each one so it's a resource that coders can then use without having to do it himself each time.
Absolutely, that would be great if there was a more generalized kind of structure that people could do the groundwork for and then just apply it in different fashions. Just like the user interface control would work. I guess we're already starting to do that, where Tom invented the tree structure for use in the outline, and that's something that perhaps could that be potentially reused in another sort of format? I guess that's just a certain step along the way. It certainly would make things much more easy, but just every day goes.
Yeah, and then you go to the department, there's still lots of fun stuff. I think you could go to a monthly function, and departments could access potentially, so that would also enhance the plugin for making the speed at which people will develop plugins if they're developing very quickly or the code editor, that kind of thing.
I have a couple comments.
may be ignorant of this, so this may not be a problem, but one of I really like using it as a tablet. So, and I played with a program called, I can't remember what it's called now, but basically you can sculpt by using it, painting, and you can do pushing and pulling. Well, there was one even before that was even Morphium. Yeah. It was like a very low cost program. But I think there are devices here now today that can be used to think about new ways of manipulating objects that we should look into integrating. But the other comment I have is I think that what we just talked about here is that there is a real balance, and I think a good example of a program maybe went too far with trying to put everything into the, I don't know how many people play with true space, but there's some things that are done really great, like putting a page on an object and having manipulators, but everything is an icon and it gets kind of ridiculous, so I think there is an important part to strike the balance.
So what are you today we have today, 5 instructions will have graduates cultural, but these items sketch out of the program and have different ways of working with I think what we could do is what is this alter and action and a further stroke and define like metaphors, but not really work out with them. Probably abstract weird interfaces, we would have to learn exactly how to use it. The action is like a power metaphor. We do a lot more with it. But then you have to think about what is that action, what kind of feeling, this is what this, what kind of tools we have, really action editing and not clicking on abstractly on squares and move them around.
We've got time for maybe one more.
Considering the complexity Blender has as a professional tool, all the functions you have, would an enhanced keyboard sort of thing be feasible for Blender? I don't know if you know the Anymotion keyboard that kind of gets used with Maya and 3ds Max. It has not just has special programmed buttons, but you have like rollers you can turn and dials, and you have like sliders for manipulating eye-pose and stuff like that. And I could imagine operating Blender with a keyboard like that could be very fast and very easy. Feasible to something like that.
Implemented a controller API, so now you can use the devices
The reply is that it's definitely something worth looking into. I guess it ties into that whole idea of mapping 2D into input devices to 3D. There's probably a lot of literature out there about how do you map a dial into 3D or how do you map a sliding thing into 3D. It's something that would be very interesting to investigate.
Okay. What was the comment? I understand there's an API ready for input with alternate devices, or what did you say?
Yeah, the game has got an API to define actions of the device to certain UI
actions. The game.
Yeah, the game.
Yeah, that would be.
It's about that one day, I very well with illustration working. I think the time should be the first thing we should work on. More than we should gather but 3D input device is attractive, that all and stuff. I think the only kind of in laboratory specialist. It's very difficult to make something work in Blender, while you immediately would think, well, you have such tools, you would class to concentrate and entirely different interface from. And all of that one using software project. Remember, you have to stick to this stupid keyboard and one mouse, and you have to think of how to use that to the maximum and also to the limitation of the practical.
Okay, I think that'll do for now.